Hello, welcome to Mr. Abbott's math videos. We are now on Learning Guide 4 and we are going to be looking at exponential functions. Okay, so we're on Learning Guide 4. So we're going to go through a review of the exponent laws, things we did back in grade 9 and 10. So we will just go through some examples here. So with the multiplication, we have a law that if we have, let's say, a base, now we're dealing with everything that has the same base. So say base 2 to some number 7 times base 2 to say 5. What we do, the laws tell us, is we add those exponents. So the answer is 2 to the 12. All right, if we have division, so let's say let's do a different base. Let's say 5 to the 6 divided by 5 to the 3. Now the laws say we minus. So we get 5 to the 3. All right, the next one I call power to power, power to power. So we have a base, let's say we have 3, and it's got a exponent there, and it's got a bracket, and it's going up to another exponent. So power to power, the laws say we times. So we go 5 times 2 is 10. Now, if we have a negative exponent, all right, so let's say we had 3 to the negative 2, we would write this as 1 over, because the 1 over gets rid of this negative sign. So, and then that just drops down as that, so it simplifies to 1 over 9. And then any base to the power 1, doesn't matter if it's 100 to the power 1, it's just itself. All right, and the last one, anything to the power of 0. So if I had 7 to the power of 0, it's 1. If I had 3, z to the 7, a to the 4, b to the negative 3, all to the exponent of 0, it's 1. All right, so let's look at some characteristics of exponential functions. So first thing here, we have an exponential function. So the example I have right here is y equals 2x. All right, so the first thing we want to do is just let's get a sketch of the graph. So over here I set up a little table of values, or input output, so we can create some values. So if I put negative 3 into that x, I am going to get an output of 1 over 2 to the power 3, so it's 1/8. And if I put 2 into there, I get a quarter, I get a half, I get 1, I get 2, I get 4, and I get 8. All right, so that's just putting the input in, output out. So now let's sketch this graph. Now before I sketch the graph, I'm going to put in the asymptote. Because the asymptote right here is very important when you're doing these kinds of functions. So if we look at this function, so I'll just write it down here, y equals 2 to the power of x. Well, if you look at what's out here, there is nothing out there. Therefore, that means that the horizontal asymptote, we say HA dot dot, is y equals 0. So I know that there is a line right there, and you can label as y equals 0. Now watch, if I make this y equals 2x plus 3 now. So now I have a number here. So therefore I know the asymptote, if I'm sketching this function, is going to be at 3. So 1, 2, 3. All right, so there's the asymptote, y equals 3. Okay, so this number out here will be your asymptote. Now, let's take these coordinates and plot them. So x is -3, and we're going up a bit. And then it's -2 and up a bit, over -1 and up a half, 0, 1. And then it's going 1, 2, and then 2, 4, and 3, 8. So you can sort of see there is the sketch of that function. Okay, now let's answer some more questions here. What is the x-intercepts? Well, because there's an asymptote on the x-intercept, there's none. You cannot cross an asymptote. What is the y-intercept? Well, the y-intercept is right there. So we would say 0, 1. Now, if we look at the domain and range, well, the domain is XER because it goes forever that way, and it's going to continue going ever right. And the range is going to be y greater, not equal to 0. All right, so now let's look at comparing some of these functions. So first of all, I'll do the first one we have, y equals 2x in green. So you can sort of see it on your sheet. It's there, 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 there. Okay, so now let's compare this guy. So if we look at that, hopefully you can see there is a negative sign right there in front of the function. So going back to some previous learning guides, when we had y with a negative f of x, all right, you recall that if there's a negative in front, it is a reflection on the x-axis. So this one would look like that. All right. Now the next one, you hopefully can see the negative is there now in front of the x, and that is the reflection on the x-axis. Pardon me, a reflection on the y-axis because it's affecting the x values. So it looks like that. Now the next one's a little trickier because if you look at this is 4 to the x, and everything we're trying to do is got a base 2. So what you have to recognize is you have to rewrite this, rewrite it as y equals 2 to the power of 2, because 2 to the power of 2 is 4, so same thing, and then x. So now, I know that this number in front of the x is affecting the x, and so it is a horizontal compression, so it's being compressed in. So I can see that this one is going straight right up. It's going quite steep. Okay. And now the last one, again, we have to do a rewrite because this guy is a half, not base 2. So it's 2 to the negative 1. So that's what a half is, to the x. Now I see there's a negative 1 in front of the x. So it is the same as b. So I know it's a reflection on the y-axis. All right. Now we can just describe what's happening. What's happening with A? Well, hopefully you see reflection on x-axis. B, reflection on y-axis. What happens to the function when b gets larger? Well, we can say it is a horizontal compression. And what happens to the function when it's between 0 and 1? It becomes reflection on y-axis.